Hello and welcome again to Algebra 1 Honors. Today we're going to be looking at lesson 6-1, which is simplifying fractions. Okay, the first thing that I want to talk about when we simplify fractions is that what we have to do first is we have to factor both the numerator and denominator, and then we're going to look for like terms or terms that are the same and cancel them out. Okay, so let's look at an example. Okay, let's look at this example here. 3a plus 6, 3a plus 6 over 3a plus 3b. Okay, in this case here, okay, the only thing that we can do to factor these guys is find the greatest common factor of the numerator and the denominator. Okay, let's look at the top one. The greatest common factor of these two numbers, and here's how we can figure it out. If you can't see it, we break it down into its prime factorization. So 3 is actually 3 times 1, or 3. And then the other guy is going to be another 3. And then we have an A and a B, but they're not going to be common. So the only thing that's common is a 3. So let's look at it. We're going to take the 3 out of the top, and we're going to say, and we use a distributive property, 3 times A, and this guy's going to be what? 3 times what will give me 6 is going to be 2. Okay, and then that's going to be over the bottom. We're just going to take a 3 out of there. That's the common factor, and it's going to be A plus B. Now, whenever you multiply two numbers together, if it's multiplication, you're allowed to cancel. The only time you can't cancel, if this would be 3 plus A plus 2 over that, you wouldn't be able to cancel. Because they're both multiplication, we can cancel these off. 3 over 3 is 1, and we can rewrite it, and our answer will equal A plus 2 over A plus B. Okay, this is a very simplified version, and as you can see, as we progress, we're going to use all the things we learned in Chapter 5 about factoring, and we're going to do the same thing, just on a little higher level. We're going to factor the numerator and factor the denominator, and then we're going to look for things that are multiplied together that we can cancel out. Okay, now before I move on, I'm just going to ask you a simple question and see if we can do this. Okay, can we cancel out A plus 2 over A plus B? Is there anybody here thinks that maybe these two A's should cancel out? I hope not, because in algebra, because these are both being added, you can't touch them. They're off limits. They're like the outer limits. Okay, so don't fall into the trap. If you get something that's not multiplied, you have to leave it alone. Okay, conversely, what if I had this? What if I had A, and I'm going to put a little dot here to represent multiplication, A over A times 2, and then A times B. In this case, I'm multiplying both of these. So what can I do? Because I'm multiplying, I can do what? I can cancel out the like terms. And that's basically what we're going to be doing with these examples, except we're going to cancel them out, and this is going to turn into a gigantic 1, and the answer for this guy will be 2 over B. Okay, so let's go to a little more difficult problems, and we're going to have to use, the only difference from these problems and the ones we're going to work now are that we have to use some more of our factoring skills that we learned in Chapter 5. Okay, let's look at this one, example 2. Okay, x squared minus 9. Right now you should be saying to yourself, gee whiz, that looks like the what? Difference of squares. It is. And then they already factor this for you. They say 2x plus 1 over 3 plus x. Okay. Now we're going to go ahead and reduce this. But before we reduce it, we should always remember that our denominator can never be 0. Okay, we're going to work a few of these problems, and we're going to name what the values of the variables should not be. And then at the end of this lesson, from then on until the end of the book, we're going to assume, that all the domains for the variables will not equal 0. Okay, so we won't have to worry. Okay, let's look at this one. We should know from chapter 5, difference of squares is going to be x minus 3 times x plus 3. Okay, so we have to change that. We have to factor that, and this guy's already factored. Okay, and he's going to be 3 plus x. Okay, now let's look at this for a minute. If you remember the associative property of addition, it says that if I have 3 plus x, I can take the commutative property, I can flip this around and make it x plus 3. Okay, it could be 3 plus x or x plus 3. So on the top I have x plus 3. So down here, just to make them similar, instead of writing 3 plus x, I'm going to just take this and flip it around, which would be x plus 3. So down here, we're going to make it x plus 3. Now you can easily see, and sometimes you got to use your eyeball and say, hey, you know what? That's the same as that, and all they did was take the numbers and they flipped them around. They commuted them, commutative property. They took them from one place and put them the other. And so now we're ready to go. We can see that this guy here and this guy here can cancel. How about these two guys? No, nothing there can cancel. So we have x minus 3 over 2x plus 1. And just for the heck of it, if you were going to name the variables that could never, the numbers of the variables that could never be, because it would make the denominator 0, in this case, we would see that if x was negative 1/2, this guy would be 0. And over here, we see that if x was negative 3, this guy would be 0. We're only going to do this for a few problems, and then we're going to assume from then on that our denominator is not going to be 0. Okay? So I just want you to make sure that you know that division by 0, okay, is undefined. You cannot do it. It's not allowed. All right, let's look at the next example. Okay, now the next example is a little more difficult because we're going to have to factor a little bit more. So we have 2x squared plus x minus 3. This is going to be special factoring. And this guy down here is going to be 2 minus x squared. Okay, so let's go ahead and factor the very first guy on the top. Okay, it's going to be special factoring. Now remember, in special factoring, we take our leading coefficient 2 times negative 3. So we're looking for a number, when we multiply together, it will give us a negative 6. And when we add them together, will give us a 1. Okay, what could give us a negative 6? How about a negative 3? Oh, that's not going to... How about a positive 3 and a negative 2? That will give us a negative 6 when we add them together. But now we have to go ahead and divide by our leading coefficient. So we're going to get 3 over 2, and we're going to get minus 1 over 1. So the top number is going to change. I mean, we're going to factor it into 2x plus 3 times, okay, x minus 1. Okay, so what we did is we've already factored this. Let's look at this bottom guy. Whoa, he's a little different. Okay, we've got 2 minus x squared. Here's what I do to make life easy and simple. What I do is I put a negative sign out in front of this guy, and I kind of rewrite it. I rewrite him like this. I put a negative sign out here, and then I put my x squared first. X squared, and this guy's going to be a positive x minus 2. And this is the one, I'm going to put this up here like this. Okay, and this is the one that we're going to now factor. Okay, so we're going to be looking for a -2. When we multiply it together, -2 and a 1. Well, that could be what? 2 and -1. 2 times -1 will give me -2. And when I add them together, it'll give me 1. So the bottom here is going to turn into this. Or actually, it's going to turn into, negative sign comes out here, and it's going to be x plus 2 and x minus 1. Okay. Now, do I have anything I can cancel out? I sure do. I have an x minus 1 and x minus 1. So these cancel out. And my answer is, you see I have a negative sign here, so I can go ahead and put him in the very front. Does it matter if the negative sign's down here, up here, or out in front? No. It's all the same. But normally, when they finish problem, they put it out in the very front. So the answer to this problem will be, whatever's left over, it's going to be 2x plus 3 over x plus 2, and it's negative 2x plus 3 over x plus 2. Okay, let's look at example 4. In this example, they're going to ask you to solve for a variable, okay? And we're going to have to use factoring to do that. So let's see how this is going to work out. Okay. All right. In this case, we're going to have ax minus a squared, okay, equals bx minus b squared. Okay, and we're going to solve for x. Okay, in this case, when we're solving for a variable, we want to get that variable on one side, and everybody else we want to put on the other side. So in this case, I have an ax here and a bx. So I'm going to take the bx and move it over. So I'm going to subtract bx from this side, and I'm going to put bx here. So I'm going to have ax minus bx. Then I'm going to have a minus a squared here equals minus b squared. Okay, so now I'm going to take my a squared and put him over here, positive a squared, and a positive a squared, and we rewrite this as ax minus bx equals a squared minus b squared. Whoa, what do we got over here? Again, a little alarm should be saying, hey, I know that from chapter 5 factoring. That's a difference of 2 squares, and it sure is. All right, so what we're going to do is take the greatest common factor out here, which is an x, and that's going to leave us with a minus b over here. And over here, we're going to have what? A minus b times a plus b. Okay, the difference is squares. Now to solve for x, all we have to do is divide by a minus b. So we divide this side by a minus b, and we divide this side by a minus b. Okay, this will cancel out and make it 1, so we'll have x equals, and over here, what can cancel out here? Well, a minus b. So this will cancel and this will cancel, and that'll make it a big 1 here, 1 over 1, and I'm only going to be left with x equals a plus b. And if we're going to name the variables that we shouldn't have, the only thing that a cannot be equal to b. If they are, then you get no. A cannot be equal to a negative b. And if it is, if a is equal, then you would have a 0 and it's equals. What?
They can't be equal. A and B cannot be equal.
Oh, A and B. A and B cannot be equal. A cannot equal B. Okay. All right, so that takes care of lesson 6.1. Okay, and how do we do that? We looked up here and we found out that if A equals B, for example, if A is 2 and B is 2, we would have 2 minus 2, which would give us a 0 here, and that would be a non-starter. That would be something that we shouldn't do. It's undefined. Okay, all righty.